Hello, welcome to math class. I hope you're having a wonderful Monday. Here's a little lesson for the day. This is what we're doing this week. We are learning today the standard form of a linear equation, tomorrow the slope-intercept form of a linear equation, Wednesday is word problems, Thursday I'll be back with you live in person, and Friday we will take a quiz to end the week, and then you have a week off. So let's get into it. All right, here we are. We did a quiz over learning intention 1 and 2. There are many of you who probably have a surprisingly low score on that quiz. That's not unusual since it was over so many different little math concepts. There was a lot of you who had some of this going on where you like knew all of the things, and then when you took the quiz they all kind of just went like this in your brain. So you're going to get it back and we'll be able to work the bugs out, and you'll have a second opportunity to improve your grade on it when you take the summative that's coming up. So treat that as a learning experience. You will get it back. You will get to see what your mistakes were. This week we are doing learning intention 3, which is graphing in standard and slope-intercept form. Standard is today, slope-intercept is tomorrow, and then Wednesday we'll do learning intention 4, which is being able to do it as word problems. Okay, so let's get into the actual math here. When you are fully invested and fully knowledgeable about all the things about linear equations, you will see that there are 3 different ways that you can write a linear equation. One is standard form, the other is slope-intercept form, and a third is called point-slope form. That one is coming in January. And the reason why would math people do this to you, make you learn 3 things, is because each one of these sort of has its own superpower, its own thing that it's really, really useful for when given different types of real-world situations. So you'll hopefully, as you go through this class, say like, oh, that's a situation where I would need to have this tool in my toolbox. Or this is a situation in which I would like to have this tool or this tool. Again, these are the 2 big ones we're covering this semester. We're going to hit that one when you come back in January. All right, so today's topic is the standard form of a linear equation. As it says in pretty much any textbook that you would come to, the standard form of a linear equation is this form, ax plus by equals c. I wrote it a little bit bigger here so that you can see it. What you're doing is you're kind of thinking about that in math class when it's a generic formula like that as being an x-ray, right? So you're looking at the x-ray of the structure and you're wanting to see if it matches what you were given. It's sort of like if you see some dinosaur bones, and you're like, what kind of a dinosaur was this? Well, by knowing what a Stegosaurus fossil looks like, you're able to identify this maybe as a Stegosaurus fossil, or maybe as a Tyrannosaurus rex, or whatever it is. And so you have the structure here, and then when somebody gives you something like this, and they say, hey, I just dug up these bones right here, does this structure match that structure? You can look at it and say, oh yeah, there's number x plus number y equals number. And so you would say that 9x plus 5y equals 87 does match the structure of a standard form linear equation. All right, so what about this guy? If you look at this one, you're like, well, there's x's and y's in there, but if I line things up, it is definitely not in that structure. Now you guys have the algebraic skills that you could rearrange that, and that's something we're going to work on later. But for now, you just say like, is this a Tyrannosaurus rex? No, it's not. That's a Tyrannosaurus rex. This is maybe a Triceratops or something like that. They have a different structure to their look, right? All right, so I gave you some examples on this slide of what it looks like and what it don't. All right, look at this one right here, this top one. Again, this is something we came up with last week as well. The minus sign doesn't cancel out it not being the same sort of structure because we can always write a negative as adding a negative, right? And so this is ax plus negative 7y, which is the b, equals c. So in this case, our a would be 5, our b would be negative 7, and our c would be 35. Here's another example of one that works. You might think to yourself, uh-oh, it doesn't work because there's no number on the x. Well, we know that whenever there's not a number on the x, that we just have the coefficient of a 1 hanging out in front of it. So this definitely is the a is 1, the b is negative 4, the c is 937. Bring it up to this one. This is a pretty standard one that looks exactly like it. And then you would have this one as well that sometimes people might think doesn't fit the structure, but again, it's got that little one trick hanging out right there, okay? If you bring your little skeleton over here, you'll see that that one just doesn't match up. It's just not the same structure. The x and y have been multiplied by each other. This one, again, doesn't have the same structure. This one you might think is close because it looks like ax plus by equals c, but the whole thing that's ruining it is that little guy right there. You can't have either of them being squared. As we talked about last week, squaring makes it do the kind of curving stuff, and you get the parabolas, which is what you're going to learn about in math 2. All right, so we are supposed to be graphing these things, right? We said it's a linear equation. Since this is a standard form of a linear equation, we are going to hopefully end up seeing a straight line up here on the graph when we graph it. So what would this look like? Well, we're going to figure out what this looks like by picking some x's and seeing what y's go with them. So we can pick literally any number we want for x. I almost always start off by picking a 0 for my x. If I plug that 0 in here, I get 0 times 0. What is 0 times 0? You're right, it's 0. So we have 0 plus 3y equals 18, which is effectively just 3y equals 18. I solve that by dividing by 3, and I get y is equal to 6. So I know that if I put a 0 in, I get a 6 out of this machine. Okay, I'm going to erase this work so I have room to do some other stuff. But I'm going to plot that as a point and put a dot at 0, 1, 2, 3, 4, 5, 6, and I put a dot right there. Okay, now what happens if I put a 1 into this machine? Well, if I put a 1 in, right there, what is 0 times 1? It's also 0, and so this one also acts like 0 plus 3y equals 18, and we already know that that is going to be equal to 6. Pretty quickly you discover that no matter what you plug into this machine, if you put a 5 into there, you're going to get 5 times 0, and you're going to end up with 6, that you're always just going to keep getting 6's for your y's, and so your dots are going to go like this, and then the red dot would be like over here. And those dots line up in a perfectly straight line, but it's a perfectly horizontal straight line. And so we would graph that one. Let me erase this really quickly. We would graph that one, and we would get a perfectly horizontal straight line. Don't judge my unperfect, perfect line right there. So anytime that you are basically missing the x, this is a huge conclusion that I would like you to write in your toolkit at some time. You can do it later on in the lesson too. If you have only y's with no x's showing up, you're always going to get a horizontal line like that. Okay, next one. This is a similar pattern, and if you're predicting and you're sort of looking for patterns here, you can see that there is something similar going to happen. Notice in this one, the y got multiplied by 0. So in this one, it doesn't matter what the y is. No matter what the y is, we're always going to be left. It doesn't matter what I plug in. We're going to get 5x equals 10. Divide by 5. Sorry, I almost gave away the answer there. Which gives you x is equal to 2. And so it's going to be 2, 0, 2, 1, 2, 9, 2, negative 437. The x is forced to be 2 because there is no place to put a y that's going to make anything other than 0. And so a dot 2, 0 would be like 1, 2 right there. The dot 2, 1 would be over 2 up 1 right there. The dot 2, 9 would be like right there. And you can quickly see that when you get this type of equation, an equation that is all x with no y, you're always going to get what kind of a line? Vertical. Yeah. Okay. Horizontal looks like the horizon of the earth. It's flat this way, although the earth isn't flat. You didn't hear me say that. I'm not a flat earther. And the all x and no y goes like this. That is vertical, okay, up and down. All right, so that is here. This is a good place for you to maybe pause the video, write this in your toolkit. Horizontal and vertical lines. If it's all y with no x, it's going to be horizontal. If it's all x with no y, it's going to be vertical. All right, that's easy. But what about if we actually have coefficients for both of the x and the y? Notice how none of these have a 0. These things cannot be horizontal and cannot be vertical, so the only other option for these is to be tilted lines, right? They have to have some sort of tilt to them. So here's the magic for how you get what the tilt is. All right, this is something that I call the table trick, okay? I sometimes call it the table trick. I sometimes call it the cover-up method. And you'll see why as I show you how to do this. When you are given an equation in standard form, the first thing to try is to just make a little table and put a 0 in for the x and then put a 0 in for the y. What that does is it ends up acting like those ones we just did, because if I put a 0 in for the x, I get 2 times 0, which effectively makes that just go away. That's why I call it the cover-up method. It's like you're just covering up that one with your hand. And now you have an easy equation to solve. You have the equation 3y equals 12 to solve. So 3y equals 12. If I divide both sides by 3, I get y equals 4. So when I plug a 0 in for my x, I end up with a 4 for my y. So that is a coordinate point. That is the point 0, comma 4. So I'm going to go over 0, up 4, and put a dot right there. All right, the next point that I choose, and the reason why we choose this is because it makes our lives really easy. We don't have to choose zeros, but 0 is the beautiful number because it makes things disappear. It automatically makes our equation easier to solve. So now I'm going to take away my green stuff here, and I'm going to plug in a 0, but now I'm plugging it in under my y column, so the 0 goes in right there, and that effectively just makes that disappear. So I cover that up. And now I'm left with the equation 2x equals 12. So that looks like this. 2x equals 12, divide by 2, and I get x equals 6. So the x value that goes with the y value of 0 is 6. That is the coordinate point, 6, comma 0. So I would put a dot right there. If I have 2 dots, and I know for sure that it's going to be a straight line because of the skeletal structure of it, whoops. If I know for sure that's ax plus by equals c, we've defined that as a linear function. This has to be a straight line, so there's no wiggles or anything in there. I'm going to go like this and just connect those 2 points with a straight line. And that would be the graph of that function. Notice how it's got the tilt, because it has x's and y's involved with it. Notice how I didn't just stop at the dots. This is a straight line that goes on forever in both directions. So when you're given one of these, you should plot your 2 dots, connect it with a straight edge if you have one. You can always use like the edge of a notebook or fold up a piece of paper to get a nice crisp edge. Put arrows on the end of it and go through the entire distance of graphing space that you have to work with. Okay, a couple quick examples. You're almost done with this video. If I ask you to graph this one, we have negative 3x plus 4y equals 12. That does match standard form. So I'm going to do the table trick. I'm going to put a 0 in for my x. By putting a 0 in for my x, I get negative 3 times 0, which effectively just makes it go away. Again, the cover-up method, right? I get 4y equals 12. I go 12 divided by 4 to solve that equation, which is 3. So then I go over here and I put a dot at 0, 3. Okay? Make sure when you're doing this that you go next door to each other. A lot of people go 0, 3 like that. You don't want to go up and down, you want to go across because you want to get the coordinate point 0, 3. All right, now I'm going to switch colors and I'm going to pick a 0 under here. The table trick, I always pick 0 here, then 0 here. Putting a 0 in here effectively makes that one go away because 4 times 0 is 0. And I get negative 3x equals 12. Now solving that one is 12 divided by negative 3. 12 divided by negative 3 is negative 4. So now I put a dot at negative 4, 0, which is right there. And I've got my 2 planning dots that I can use to create my perfectly, don't judge me, straight line like that. Okay. What about this one? 9x plus 4y equals negative 36. Pretty much it ends up being the same thing over and over and over again. The only thing I can do to mess with you is to kind of like put more negatives in here. So if you're solid with your negatives and you're careful with this stuff, it should be really easy. Put a 0 in under my x. Put a 0 in there, it makes that disappear, and I have negative 36 divided by 4. I'm going to show that one again because sometimes people have trouble understanding what I'm doing there. By putting a 0 in, I get 4y equals negative 36. I solve that one-step equation, and I go y equals negative 9. Now, what you're going to get good at, hopefully, is realizing it's always the same sort of one-step equation. You get to the point where you can start kind of doing it in your head, right? And so that's the point 0, negative 9. Ooh, I got to go down here for the first time. There's 0, negative 9. I'm going to put a 0 in for my y. Putting a 0 in for my y, I cover up that. Looks like I have a tattoo of a 4y on my hand. Maybe I'll get that. Speaking of which, did you notice during this video? Yeah, my daughter has a cat. I've never had a cat in my life. My daughter has a cat, and for the first time ever, it was being really nice to me last night. And I was petting it, and I was petting it, and the cat was going, yeah, I like that, I like that, I like that. And then all of a sudden I petted it one more time and the cat was like, death to you. And so she got me a little bit. Anyway, fun side story. Oh, where were we? Oh yeah, math. I put a 0 in for this. I made my tattoo joke. We have 9x equals negative 36. Negative 36 divided by 9 gives me negative 4. So I put a dot at negative 4. I connect them with a nice perfect straight line. Don't judge me. Okay. Last one. I think, yes, okay, last one. If I put a 0 in for my x, makes this go away. Okay, this one I made as a special instance because a lot of people will cover up too much. Make sure when you cover this up that you don't cover up the sign here because you need to realize that this is 10 divided by negative 5, making that be negative 2, 0, negative 2. It's also a common mistake that people put like 0, negative 2 right there. Make sure you force your brain to go over 0, down 2. Next, I'm going to put a 0 in here, which effectively covers this whole thing up, and I get 10 divided by 2, which is 5. So I put a dot at 5, 0, which is right there, and I get this sort of happy thing going on. And there's my graph. Okay, here's your assignment for today. Mr. Hammerly is here to help you. He's a good guy. Don't be afraid to ask him questions. All right, work to do. You have a standard form worksheet. You also have a new Delta Math assignment that's out. I promised you that it would be shorter. It is shorter. There are some of the ones on the Delta Math that you probably can't do yet because I haven't taught you them. I put basically the whole week assignment together. You should do any of them that look like standard form. If you click on one and you like, Mr. Cianfrance hasn't taught me how to do it yet, it's because it's coming later in the week, okay? If you already know how to do it and you want to crank it out, that's great. You do have to watch these Edpuzzle videos though, because these are showing me that you are actually learning math. Even if you already know it, because I might say something that you don't know, or maybe I won't, or maybe I'll just tell you a fun story about me getting injured, or maybe I'll tell you a really good joke. Next video, I promise you a joke. All right, you know what you need to work on. Get going on it. Hope you're having a good week, a good day. Talk to you later.